Okay, so let's take a look at an example. This is from practice quiz 3, number 1. It says initially 2000 milligrams of a radioactive substance is present. After 8 hours, the mass has decreased by 5%. If the rate of decay is proportional to the amount of the substance present at time t, find the amount remaining after 36 hours. Okay, so let's first let's define, say, x of t to equal the amount of radioactive substance present at time t. So let's do that. Okay, so x of t, amount of radioactive substance present at time t. Here, t, we're assuming is measured in hours, since we're given this in 8 hours here. We're looking for 36 hours. Okay, so we're given at time 0, there's 200 milligrams. And we're also given after 8 hours, that means x of 8, it's decreased by 5%. That means there's 95% of the 2000 left. So let me write that down here. Okay, so we have x of 0 is 2000 because at time 0 there's 2000 milligrams. And x of 8, so after 8 hours, it's decreased by 5%. That means there's 95% of the 2000 left. So it'd be 2000 times 1 minus 0.05. So it'd be 1900 milligrams left. Okay, so next thing. So next thing is, it says the rate of decay is proportional to the amount of substance present at time t. So rate of decay would be dx dt, and that would equal then some constant times x. So let me write that here. Okay, so we also have then dx dt equals k times x. That means proportional to the amount present at time t. I'm leaving off the x of t here and just running it as x. And we can notice actually this is a separable differential equation. So let's get all the dx's and x's on one side and all the dt's on the other side. So doing that, we get then, so again, note this is a separable differential equation. So pretty much then I'm dividing both sides by x, multiplying both sides by dt to get this. So it'll be dx over x equals k dt. And now we can integrate both sides. So doing that, we get then, so we get this then, it'll be integral of 1 over x dx. I'm writing the dx over x as 1 over x times dx equals integral of k dt. So integral of 1 over x would be ln of x. Integral of k would be just kt plus some constants. Let me write that here. Okay, so we'll have then ln of x equals kt plus c. Now I want to solve for x, so let's exponentiate both sides with base e. So doing that, we get then, so we get this, and let's break this guy up here. So I'll write another piece over here. So doing that, we get, so breaking up, we get this then. And the e to the c, I'm just going to call c1, and here the ln and e cancel, let's get x then. So I write my answer over here. So we get then, so I get x, but I'm writing it now as x of t. So it'll be x of t equals c1 e to the kt. Now we're going to use our initial condition that x of 0 equals 2000. Let's use that one first. So using that. So now using x of 0 is 2000, so you're putting 2000 in place of x of t over here, 0 in place of t here. So you'll have then 2000 equals c1 e to the 0 power. E to the 0 is 1, so we're basically going to have c1 equals 2000. Okay. Okay, so c1 is 2000. So I'm out of space now, so let me erase a few things and we'll keep going. Okay, so summarizing, we have our x of t equals 2000 e to the kt. We still have to find this k, but we also were given that x of 8 is 1900. So let's use that one next. I'm going to put 1900 in place of x of t here, 8 in place of t here. So doing that, we get then, Okay, so we get then, so again, putting 1900 in place of x of t, so we have 1900 equals 2000 e to the 8k. Okay, let's divide both sides by 2000 now. Okay, so dividing both sides by 2000 here, got 1900 over 2000, two zeros cross off, 19 over 20. Now to solve for k, let's take the ln on both sides. So doing that we get then, so taking ln on both sides we have this. I could bring the 8k now in front. So doing that we get then ak ln of v equals ln of 19 over 20. ln of v is 1. So solving for k then dividing by 8 we get then, so we have then k equals ln of 19 over 20 divided by 8, which is roughly equal to, you can check on your calculator, negative 0.00641. Okay, so now we need to find x of 36 because we're looking for how much substance remains after 36 hours. So we can find that now. Okay, so we need to find x of 36. So we're going to be using our equation we developed up here. So the 2000, the coefficient in front of the e, and then it's going to be e to the k. So the k we find is up here, negative 0.00641 times t. Our t here is 36. So you're going to plug into this guy here. So I'll let you check, if you stick that in your calculator, it's roughly equal to 1,587.86. And that's going to be milligrams. So that's how much will remain after 36 hours. Okay, so we're done with the question.